is Edexcel's Mathematics GCSE Practice Set 5, Paper 1H. Question 1. Find the highest common factor of 12 and 20. You can do this by finding just the factors and finding the highest one. I'm going to do this with a Venn diagram just so that we're getting to good practice. So if we break it down into its prime factor decomposition, so 12 would be 2 times 2 times 3. 20 we can break it down to 4 times 5. 5 is prime. 4 can be 2 times 2. And if we put this into a Venn diagram where the left is 12, right is 20, then we'll have 2 2's in the middle. We'll have a 3 for the remaining 12 and a 5 remaining for the 20. So the highest common factor will be the two numbers in the middle, so 2 times 2, which is 4. Again, I'm going to use a Venn diagram for this, so the lowest common multiple. So if we break 32 down into 2 times 16, which will be 2 times 8, 2 times 4, and 2 times 2. So 32 is 2 to the power 5, and 48 will be 2 times 24, which is 2 times 12, which is 4 times 3, and 2 times 2. So if we put this into a Venn diagram, 32 on the left, each one has 4 2's in it. So we can have 2, 2, 2, and 2 in the middle, and there is a remaining 2 for the 32. And for 48 on this side, we've got the 4 2's already, and we need a 3 on this side. So to get the lowest common multiple, we multiply all the numbers together in the Venn diagram. So if we multiply all those together, we get 96. Question 2. 5 schools sent some students to a conference. One of the schools sent both boys and girls. This school sent 16 boys in the ratio 1 to 2 for boys to girls. So boys to girls in the ratio 1 to 2. So there are 16 boys, which means there must be 32 girls. Altogether, that is 48 students. It says the other 4 schools sent only girls, but they all sent the same number of students. So that means that all schools, all 5 schools, must have sent 48 students. Now we are asked for the total number of students, not boys and girls. We just need to do 5 times 48, which is 240. Question 3. Work out the value of 6 times 10 to the power of 8 times 4 times 10 to the power of 7. To multiply in standard form, we just do the integers, so 6 times 4 is 24. Then do the powers of 10, so 10 to the power of 8 times 10 to the power of 7 is 10 to the power of 15. So that will give us 24 times 10 to the power of 15. Now, unfortunately, that's not in standard form, because standard form has to be between 1 and 10. So if we change that to 2.4 by dividing by 10, to compensate for that, we need to multiply by 10, so we 10 to the power of 16. Work out the value of 6 times 10 to the 8 plus 4 times 10 to the 7. Now, to do this one, we need to write it out in full as proper numbers. So 6 times 10 to the 8 will have 8 zeros on, and 4 times 10 to the 7 will have 7 zeros on. And if we add those together, we get 64 with 7 zeros, so 640 million, which will be 6.4 times 10 to the 8. Question 4. Sam rolls a fair dice 150 times. Estimate the number of times it will land on a 4. Well, there's 1 4 on a dice and 6 numbers, and since it's fair, probability will be 1 6. So we want to do 1 6 of 150, which would be 25. Question 5. A, B, C and D, E, F are 2 similar triangles. Work out the length of BC. Well, both A, B and D, E are the bases of the triangles. So to get from the smaller triangle to the bigger triangle, we do 12 divided by 8, which gives us a scale factor of 1.5. So this side links up with the side BC, which is what we're after. So we need to do 14 times 1.5. Half of 14 is 7, so that'll be 21. Question 6. Work out a third plus 2/5. To add together fractions with different denominators, we need a common denominator. So 3 and 5 both go to 15. So we're going to make these out of 15. 3 times 5 is 15, so 1 times 5 is 5. And 5 times 3 is 15, so 2 times 3 is 6. Add those together, we get 11 over 15. Work out 2 3/4 multiplied by 1 3/5. To multiply fractions, or adding, subtracting, or dividing, actually, we need improper fractions rather than mixed numbers. So 2 3/4 would be given as 11 over 4. And 1 3/5 will be given as 8 over 5. To multiply fractions, we just do top times top, bottom times bottom. So that'll be 88 over 20, which can be written as 4 whole ones and 8 20ths. Now it asks for its simplest form, So that'd be 4 whole ones and 2 fifths. Question 7. Solve the inequality 3t plus 1 is less than t plus 12. When you've got an unknown on both sides, you need to get rid of the smallest amount off both sides. So we're going to take 1t off both sides. That'll be 2t plus 1 is less than 12. And then want to get rid of the plus 1 by taking 1 off both sides. So that'll be 2t is less than 11. Divide by 2, I get t is less than 5.5. Part B, t is a whole number. Write down the largest value that t to satisfy that equation. So if t is a whole number and t has to be less than 5.5, that must be 5 for that whole number. Question 8. The distance from Caxby to Drone is 45 miles, and from Drone to Elton is 20 miles. Colin drives from Caxby to Drone, he then drives from Drone to Elton. Colin drives at 30 miles an hour from Caxby to Drone, and at 40 miles an hour from Drone to Elton. Work out his average speed. Well, if he's doing 30 miles an hour from Caxby to Drone, 30 miles an hour to do 45 miles, that must be an hour and a half, so 1.5 hours. And then at 40 miles an hour to do 20 miles, that would only take him half an hour. So 1.5 hours plus half an hour is 2 hours. Again, you can use speed equals distance over time for that one, but it's quite easy numbers to do with common sense on that one. So altogether, he has got 65 miles to cover in 2 hours. So speed equals distance over time, so we need to do 65 miles divided by 2 hours, which would be 32.5 miles per hour. Question 9a, factorise x squared minus 49. Well, this is a special case where we can put it into 2 brackets of x plus 7 and x minus 7. The plus 7 and minus 7 will mean that the x is in the middle. When you expand those out, will disappear. Part B, expand 2y plus 7 brackets y minus 3. If we use FOIL for this, we do the first one, so 2y times y is 2y squared. The outsides, 2y times minus 3 is minus 6y. Do the insides, 7 times y is 7y. And then the last, 7 times minus 3 is minus 21. And if we put all that together, we get 2y squared plus y minus 21. Question 10. Here are the equations of 5 straight lines, A, B, C, D, and E. One of the lines goes to the point 0, 3. So the 0 is the x-coordinate, the 3 is the y-coordinate. So the 3 must be the y-intercept. So we are looking for the equation of a line that has 3 or plus 3 as the y-intercept, and that would be C. 2 of the lines are parallel. Write down the letters of those 2 lines. Well, if they're parallel, they have the same gradient. The gradient is the number in front of the x. So in this case, B and C both have a 2, so they both have a gradient 2, so they must be parallel. So that is B and C. Question 11, factorise fully 3xy squared minus 6x cubed y. Well, we can take a factor of 3 out of both of those. They've both got an x in, and they've both got a y in. So I can take 3xy out. To get back to 3xy squared, I need a y. And to get back to 6x cubed y, I need to take off 2, because 2 times 3 is 6. And x squared, because x times x will give you x times x squared will give us x cubed, and then we've already got the y. Question 12. Complete this table of values for x cubed plus 2x minus 1. We'll do the first one, and then the rest should be fairly easy. So to work out the first one, we need to do minus 2 cubed plus 2 lots of minus 2, and then take 1. Well, minus 2 times minus 2 is 4. Times minus 2 again, it would be minus 8. And then 2 lots of minus 2 would be minus 4, and take 1. Minus 8 add minus 4 is minus 12, take 1 is minus 13. So the first one should be minus 13. When x is 0, it'll just be minus 1, because all the x terms cancel out. And when x is 1, 1 cubed is 1, 2 lots of 1 is 2, and then take 1 would give us 2. Plot that on the graph. We need to go to x is minus 2 and y is minus 13. So that will be down here. Minus 1 minus 4 would be there. 0 minus 1. 1, 2, and 2, 11. And again, because this is a curved graph, we need to join it up with a nice smooth curve through all of those points, and we get the characteristic x cubed graph like an S shape. Question 13. Here is some information about 100 students. 60 study French, 36 study Spanish, 14 do not study either. Draw a Venn diagram. Well, straight away, what we should be looking at here is that obviously we need two circles overlapping, one for French and one for Spanish. Straight away we can say that 14 don't do either. If you look at these numbers, these actually add up to 110, but it says there are only 100 students. That means there must be an overlap of 10 doing French and Spanish. So we could put 10 in the middle, which would mean there's a remaining 50 that just do French and a remaining 26 that just do Spanish. One of the 100 students is picked at random. Work out the probability that will study French, Spanish or both. Well, that's all the pupils in the circles. So 50 add 10 at 26, which is 86 out of 100. Question 14. Work out the angle marked X in this regular octagon and pentagons put together. Well, I always like to find the external angles to help me find the internal angles because it's much easier. So if I find this external angle here, I do 360 divided by 8 because external angles always add up to 360, which will give me 45 for this angle. If I work out this external angle here, it'll be 360 divided by 5 because it's a pentagon, which will give me 72, which means that this internal angle is 108, taking it off a straight line, which will also mean that this here is 108. So in there we've got 45 and 108 on a straight line, which take off 180 will give us 27 for this angle here. This will be an isosceles triangle because it's got two sides on the pentagons that are equal to each other, so that will also be 27. So X will be 180 minus 2 lots of 27, which will give us 126. It doesn't ask for any reasons on this one, so we can just do all the working out. Question 15. The diagram shows two identical squares placed next to each other. All the measurements are in centimetres. Calculate the numerical value of the length of the rectangle. Well, at the minute, we've got the top is 10x minus 2. So if that's a square, I can half that to find this length, which is 5x minus 1. Because it's a square, the 5x minus 1 must be equal to the 3x plus 5. So we've got 5x minus 1 equals 3x plus 5, which gives us an equation we can solve. To solve that, we take 3x off both sides. So we get 2x minus 1 equals 5. Add 1 to both sides, we get 2x equals 6. So x must be 3. However, we're asked for the length of the rectangle, so we need to do 10 lots of x, so 10 lots of 3, take 2, which would be 28 centimetres. Question 16. S is the event picking a red counter, and the probability of S is 2 nines. Write down the value of PS dash. S dash means it's not S, so basically the probability of not picking a red counter. Now, it should always add up to a whole one, so we just need to do 1 take away 2 nines, which would be 7 nines. Miles puts 3 green blocks, 5 white blocks and 1 pink block in a bag. He takes one out, records its colour, puts it back. That's very important. Takes a second colour out and writes it down. Find the probability that he takes 1 block that's white and 1 block that is pink. So to do this, he could have a white first, then a pink, or he could do a pink first, then a white. Okay. So to do a white first would be 5 ninths, and to get a pink second would be 1 ninth, which gives us 5 over 81. And the opposite way around would be 1 ninth times 5 ninths, which would be 5 over 81. So altogether, that would be 10 over 81. Part 2, find the probability of at least one of the blocks being white. Well, there's quite a lot of ways of doing that. The best way of doing it is finding the probability of them not being white. So to do that, we can have green and pink, or we can have pink and green, or we could have pink and pink, or green and green. So probability of green and pink would be 3 ninths times 1 ninth, which is 3 over 81. And again, vice versa, that would just be opposite way around, so this would also be 3 over 81. Probability of pink pink would be 1 ninth times 1 ninth, which is 1 over 81. And then green green is 3 ninths times 3 ninths, which is 9 over 81. And if we add all those up, we get 16 over 81, but that's what we don't want, so we need to do 1 take away 16 over 81, which will give us 65 over 81. Question 17. So meat has a pond in the shape of a prism. The pond is completely full of water. He wants to empty the pond and clean it. He uses a pump to empty it. The volume of the water in the pond decreases at a constant rate. The level of the water goes down by 20 centimetres in the first 30 minutes. So, if we use that information there, the pond decreases by 20 centimetres. So the volume of water will be 20 centimetres depth times the 1 metre back, which if we put it to centimetres is 100, times 200, which would give us 40,000 centimetres cubed. And that is in 30 minutes. So that would be 80,000 centimetres cubed in 1 hour. And if we convert that to litres, sorry, it's 400,000, sorry, missing off a zero there. If I convert that to litres, 1 centimetre cubed is equal to 1 millilitre. So if I divide that by 1,000, that means it's 800 litres per hour that we are losing in water. We just then need to work out the volume of what's left. So that is a trapezium. So we need to do the two parallel sides added together. So 110 add 30, because this has gone down by 20. So that would be 1.1 metres or 110 centimetres. That's gone down by 20, so that would be 0.3 metres, which is 30 centimetres. So you add those two together and divide by 2, times by the distance between them, which is 200, and times by how far back it goes, which is 100. So if we multiply all that out, we get 1.4 million. And if we convert that into litres by dividing by 1,000, we get 1,400 litres. So that's how much water is left. So to work out the time, we need to do 1,400 divided by the 800 litres per hour that it's draining at. So to do that, it's just the same as 14 divided by 8, which is 1 remainder 6. So 1 6/8, or 1 3/4. Now to put that into hours and minutes, that'd be 1 hour and 45 minutes. Question 18. Write the following 5 numbers in order of size, starting with the smallest. 2 to the power 0, anything to the power 0 is always 1. The square root of 2, even if you don't know that off by heart, we should know that it's between 1 and 2, so it's somewhere between 1 and 2. It's actually about 1.4. Then we've got a half. 2 to the minus 2 means 1 over 2 squared, so 1 over 4. And 1 over root 2 means 1 over about 1.4. So putting that in size order, a quarter would be the smallest, so 2 to the minus 2. A half would come next, because you're just dividing a whole one into 2 pieces. Then 1 over root 2 would come next, because you're only dividing it into 1.4 pieces. 2 to the power 0 would be 1, and then root 2 would be 1.4. Simplify 2 over root 2 cubed. That means 2 times 2 times 2 on the top, which would be 8. Root 2 times root 2 is 2. And then times root 2 again is 2 root 2. So 2 times 2 times 2 is 8. And root 2 times root 2 is 2. Times by root 2 again, it will be 2 root 2. To simplify that, we would end up with 4 over root 2, just dividing by 2. We also want that to be without a square root on the bottom. So we need to rationalise the denominator. So we times top and bottom by the same thing, by root 2, which will give us 4 root 2. And root 2 times root 2 is 2 again. And then 4 divided by 2 is just 2. So 2 root 2. Question 19. On the grid, draw the graph of x squared plus y squared equals 4. X squared plus y squared is the graph of a circle. And to work out how big the circle should be, you square root the number on the other side of the equal sign. So the radius of this circle would be 2. So using a compass, you should go from -2 to 2 to 2 to -2 and all the way around. So it would have a centre at the origin and a radius of 2. On the grid, sketch the graph of y equals cos x from 0 to 360. Well, cos graph starts at 1 and it will go through 90, 180 down to -1, up to 270 and back up to 1 again up here. Question 20. Show that all of that simplifies to ax over x plus b. To simplify fractions, we want to factorise and then cancel out things that will cancel out. So on the first one, I'm going to start by factorising the bottom of the first one, because that's the easiest one to do. So I could pull out 2x squared from that and be left with x plus 3. and that gives me a big clue as to what the top must be. Now, because it's got a 15 on the end, one of the factors could be an x plus 3. So I'm going to try that with x plus 3 there. The other one, therefore, would have to have a 2x in. And to get to minus 15, that would have to be a minus 5. Now, always check that that does work. So 2x times x is 2x squared. 2x times plus 3 is plus 6x's. Minus 5x's gives you plus 1 and minus 15. So that does work. It's always worth looking for clues in these ones. The bottom of the next one, again, if we've got anything to cancel out, then it has to cancel out with something on the top of the other one. So I'm going to try straight away 2x minus 5, because the x plus 3 is already cancelled out. And to get back to what we want, we need an x to get to 2x squared, and we'd have to have a minus 3 there to get to plus 15 on the end. Again, just double check that that works, because I'm just using clues there. 2x times x is 2x squared, minus 6x's, minus 5x's gives minus 11x's, and then plus 15. So that does work. And on the top, we've just got 6x cubed. Now, lots of things cancel out there. So the 2x minus 5 will cancel with the 2x minus 5. The x plus 3 will cancel with the x plus 3. The 2 will cancel with a 6, and the 6 will just become 3, because 6 divided by 2 is 3. And the x squared will cancel with the x cubed to just leave x. So we are left with just 3x on top and x minus 3 on the bottom. Really important you look for clues on those, because if something is going to cancel out, they must have the same brackets in. So if you do the easiest ones first, then that can often give us clues to the more difficult ones. Question 21. It says A is a point 1, 3, B is a point 4, minus 1. The straight line L goes through both A and B. Is the line with equation 2y equals 3x minus 4 perpendicular to the line L? Well, first, I'm going to rearrange this into y equals mx plus c by dividing through by 2. So that'll be 3 over 2x minus 2, dividing through by 2. So the gradient of that line is 3 over 2. So the gradient of the line that's perpendicular to that must be the negative reciprocal. So it must be minus 2 over 3. So we just need to show whether the other one is minus 2 over 3 or not. So to find the gradient of L, we do the difference in y divided by the difference in x. So looking at the y coordinates, the y coordinate of the first point is 3. And to work out the difference, we take away the y coordinate of the second one. So take away minus 1. And the x coordinate of the first point is 1. And the x coordinate of the second point is 4. So 1 take 4. 3 take negative 1 is 4. And 1 take 4 is minus 3. So that will give us minus 4/3. So we can see straight away that they are not perpendicular. However, to prove that, we can multiply the two gradients together, and if that gives us a product of minus 1, then that proves that they are perpendicular. So 3 over 2 for the first fraction, for the first gradient, minus 4 over 3 for the second gradient. 3 times minus 4 is minus 12, and 3 times 2 is 6, which will give us minus 2. So these are not perpendicular. So this is not a product of minus 1, so not perpendicular.